All right, good morning, students. Today is October 22nd. Yes, the 22nd. This is week 10, and we'll be discussing Chapter 8, which is clarifying quantitative research designs. And these are our learning objectives. Identify non-experimental designs and experimental designs used in nursing studies, critically appraise descriptive and correlational designs, describe the concepts important to examining causality, examine study designs for strengths and threats to statistical conclusion, internal construct, and external validity, describe the elements of designs examining causality, critically appraise the interventions implemented in studies, critically appraise the quasi-experimental and experimental designs in published studies, examine the quality of randomized controlled trials called RCTs conducted in nursing, and discuss the implementation of mixed methods approaches in nursing studies. So how would you describe a research design? This is a blueprint or a detailed plan for conducting a study. The design, a particular design is used whether you want to describe what's going on in an event or a situation. That would be a descriptive design. If you are examining relationships among variables in a particular situation, that would be a correlational design. And if you are examining cause and effect, that would be either an experimental design or a quasi-experimental design. What is the purpose of a study? Well, to describe variables, as I said in the previous slide, to examine relationships, to examine differences among groups, or to test a treatment, that would be experimental, and to provide a basis of evidence for practice, or it could be a combination of the above. These are the four types of quantitative research designs, right, where we're measuring something. Descriptive study designs, correlational study designs, quasi-experimental study designs, and experimental study designs. Figure 8-1 is an algorithm for determining the type of study design. So here you say, start at the top, is there a treatment? No. Well, there's no treatment. Ask yourself, is the primary purpose an examination of relationships? If you're not examining relationships, then you are doing a descriptive design. If you are examining relationships, if you say yes, will the sample be studied as a single group? Yes. Then you have a correlational design. Now over here, is there a treatment? Well, yes, there is. Is the treatment tightly controlled? Yes. Will a randomly assigned comparison or control group be used? Yes. Is the original sample randomly selected? Yes. Then we have an experimental study. Okay. Now go back to the top again. Is there a treatment? Yes. Is the treatment tightly controlled by the researcher? No. Then you have a quasi-experimental study. The types of descriptive designs. Typical descriptive design, a comparative descriptive design, and a case study. These are the three types of descriptive designs. So the descriptive design is very commonly used in nursing research. It's conducted, a study would be conducted one time under one condition to describe what exists. It's conducted in a natural setting, and there is no intervention, no manipulation of variables. It identifies phenomenon, variables, and conceptual and operational definitions, and describes definitions. Other descriptive designs are cross-sectional studies, where you study a very large group, but it's done one time. A one-time measurement at various stages of a process, and it requires a very large sample. So cross-sectional, one time, very large group. However, the longitudinal descriptive design measures subjects more than once to discover changes over time. And here are some other flowcharts for you that you can look at. Here's an algorithm for determining the type of descriptive design. So if you're examining sequences across time, if you're not doing that, if it's one group, then you have a descriptive design. If it's not a one group, then you have a comparative descriptive design. On the other side, are you examining sequences across time? Yes. Are you following the same subjects across time? Yes. Is it a single unit of study? Yes. Then you have a case study. Back here. Following subjects across time? No. Data collected across time? No. Then you have a cross-sectional design. A comparative descriptive design examines differences in variables in two or more groups that occur naturally in a setting. The groups vary by one identifiable variable. For example, looking at groups males versus females, or younger versus older, or smokers versus non-smokers. Another flowchart for you showing a comparative descriptive design where you have group 1 and group 2. They're both described, and what you're doing is you're comparing the groups on certain variables. That leads to interpretation of meaning and the development of hypotheses for further study. All right, and the third type of descriptive study is a case study. And this is very interesting. It's an exploration of a single unit of study, but it's very in-depth. It's a very systematic description of one patient or group of patients to promote understanding of nursing interventions. Sample is small, but the number of variables is large. The design can be a source of descriptive information to either support or invalidate theories, and it has the potential to reveal important findings that will generate new hypotheses. No control. What are the types of correlational design? There are three types of correlational design. Descriptive correlational design is used to examine variables and examine relationships. Remember that, examine relationships that exist in a situation. So that's a purely descriptive correlational design. The predictive correlational design is used to predict the value of a dependent variable based on values obtained from the other independent variables. And it's looking at causal relationships. Model testing design is used to test proposed relationships among concepts and then measure their relationships. How much does one concept contribute to the other? Determining type of correlational design. This chart shows you, are you describing relationships between or among variables? The key word here is relationships. that would be a descriptive correlational design. If you're predicting relationships between or among variables, that's a predictive correlational design. And if you're testing proposed relationships, that's model testing design. Advantages of experimental designs. Well, in experimental designs, there's more control in the design and in the conduct of study. That leads to increased internal validity and decreased threats to design validity, and few rival hypotheses, meaning there's some other reason for things happening. You're trying to reduce bias, you're trying to reduce extraneous variables. The essential elements of experiments: random assignment of subjects to groups, researcher-controlled manipulation of the independent variable, researcher control of experimental situation and setting, including the control and comparison groups, and control of variance, how one group will vary in terms of the measurement of the variables. To control variance, you clearly spell out the sampling criteria. Who can be in the study? Precisely define the independent variable and carefully measure the dependent variable. Here's a question for you. Which of the following is not a requirement for an experimental study? Random sampling? No, that has to be in an experimental study. Control group? No, that has to be in an experimental study. Repeated measures, measuring over several times? No, that doesn't seem to belong. And control of the intervention, that definitely belongs to an experimental study. So the answer is, which is C, is not a requirement for an experimental study. What is a quasi-experimental design? A quasi-experimental design is used in situations in which complete control is not possible, and it's developed to control threats to validity or the truthfulness of the findings. As an untreated control group design with pretest and posttest. Non-equivalent dependent variable design and removed treatment design with pretest and posttest. Okay, so the key thing that I'd like you to remember is quasi-experimental design is used in situations in which complete control is not possible, and it's developed to control threats to validity. The advantages of quasi-experimental design is that it's easier to implement, more practical, more feasible. The sample selection may be a convenient sample, which then is randomly assigned to experimental or standard control, standard care, or comparison group. The findings are more readily generalized to the population of the study group. What are the study groups? Study groups. This is a term that's used in comparative descriptive studies. There's a control group and there's a comparison group. The control group has the elements or subjects who are not exposed to the experimental treatment in the study. The comparison group receives the treatment, and the other important point to know is that sometimes study groups are referred to as equivalent or non-equivalent. They really need to be equivalent. The subjects in the treatment group and the control group have to be equivalent or similar in characteristics. They really cannot differ on the key characteristics, because if they are different, then that's a threat to internal validity. What is an RCT? RCT is a term that's used for randomized clinical trial. It's considered the strongest methodology for testing the effectiveness of treatment because essential features within an RCT limit the potential for bias. So if there's a problem that we're trying to explore, investigate, the RCT is considered the highest level of research. The design uses a large number of subjects to test the treatment's effect and compare results with a control group who did not receive the treatment. Randomization of subjects is essential, and they use multiple geographic locations. This is a huge study and probably requires a lot of money to fund it, and would no doubt be funded by NIH. What are experimental interventions? Well, the interventions that are carried out during the study should result in differences when you measure on post-test, when you measure certain variables between the treatment and the control or comparison groups. The intervention can be physiological, psychosocial, educational, or a combination of these. In terms of interventions, nursing is developing a classification system for interventions, and the leader in this work is the University of Iowa Nursing Intervention Classification System. Researchers here are working on first developing the classification system, which has over, I think, 1,200 interventions, and they are leading the research to test those interventions. What guidelines can be used for appraising interventions? Ask, was any control group intervention described? Was an intervention theory provided to explain conclusions? The characteristics of intervention studies: they maximize control over factors to increase the validity of the findings. It guides the researcher in planning and implementing a study, and it's not specific to a particular study but linked to other steps of the research process. Here are 6 very important concepts relevant to study design: causality, multicausality, probability, bias, control, and manipulation. And we'll go through each one of these. Other important concepts: validity. Validity refers to the measure of truth or accuracy of findings of a study. Internal validity determines whether the study findings are accurate or are the result of extraneous variables. And external validity, the extent to which the study findings can be generalized beyond the sample used in the study. Construct validity, whether the instrument used measures what it's supposed to measure. And statistical conclusion validity, whether conclusions about relationships or differences drawn for statistical analysis are an accurate reflection of the real world. Okay, the two definitions that I think are most critical for you at this point are validity, internal and external. What is causality? Causality says that there is a cause and effect relationship between the variables. The simplest view is one independent variable causing a change in one dependent variable. So independent variable x causes a change in y, the dependent variable. So that was causality. Now, multicausality states there is a cause and effect relationship between interrelating variables. There are multiple independent variables causing a change in the dependent variable. This diagram shows you an example of causality where A causes B. A good example would be pressure on a bony prominence leads to decubitus ulcer. A multicausality, various interrelating independent variables lead to the dependent variable of heart disease. Probability. Now, you've had statistics courses, so you know what probability is, but I'll just review briefly. This is the likelihood of accurately predicting an event, the chance that a given event will occur in a situation. Variations in variables occur. Is there relative causality? What is the likelihood that a specific cause will result in a specific effect? Probability is the chance that a given event will occur in a situation, and it addresses the relative rather than the absolute causality of events. So you're familiar with the term P is less than 0.05, right? So there's a greater than 95% chance that the results are not due to chance. And there's a 5% chance that the results are due to chance. So what is bias? Bias is the slanting of findings away from the truth. It's the influence or action in a study that distorts the findings or slants them away from the true or expected results. It distorts the findings, and the research designs should be developed to reduce the likelihood of bias or to control it. Causes of bias in designs are things that the researcher does, their attitudes, their motivation, whether conscious or unconscious, things about the environment, things about the subjects or the sample. Are they representative of the population? How the groups were formed, the tools that are used, the data collection process, how long the study went on, were there changes in the individuals because of time, and the statistical tests and interpretation. What is the purpose of control in a study design? The answer is C. Increase the probability the results are true to reality. So it's very important that you'll understand the factors that are involved in control. So control is implemented throughout the design. It's the power to direct or manipulate factors to achieve desired outcomes. Control improves the accuracy of the findings. There's increased control in a quasi-experimental research design, but the greatest control is found in experimental research, okay, where there's strict randomization of subjects to the treatment and the control group. Another term that we need to know is manipulation. This is moving around or controlling specific attributes of a treatment. The independent variable is controlled, must be careful to avoid introduction of bias into the study, and it's usually done only in quasi-experimental and experimental designs. What are the elements of a strong research design? A controlled environment, selection of the study setting, controlling the equivalence of subjects or groups, controlling the treatment, controlling the measurement, and controlling extraneous variables. Why use a diagram for the design? A diagram will, the diagram clarifies variables to be measured or manipulated. It indicates the focus of study, the type of study that's being done. It identifies the data collection process, the time for the study, the treatment implementation, and the measurement of the variables, and it provides direction for data analysis. This is a diagram of a two-group experimental design. So we have the two groups here, the experimental and the control or the comparison group. They're both measured at pretest. The experimental group receives the treatment, the control group does not, and they are both measured at post-test on some dependent variable. And this is a quasi-experimental design with several post-tests. So you have the experimental and the control group. They're both tested at pretest. The experimental group receives the treatment, and they are both measured at 1 month, 2, 3, and 4 months. Replication. What is replication research and why is it important? So replication research is repeating a study to confirm the original findings of another study to determine whether the findings of the original study can be found consistently in different settings and different subjects. And replication does a lot of important things for research. It establishes the credibility for the findings, it provides support for theory development, and it strengthens evidence for practice. What is involved in critically appraising a study design? Was the type of design identified in the research report? Was the study design linked to the purpose, objectives, questions, or hypotheses? Were all the variables manipulated or measured? Which of the following does not belong in evaluating correlational design as sound? B. A low response rate is not a characteristic of a good correlational design. Appraising a study design. If the study included a treatment, was it clearly described and consistently implemented? Were extraneous variables identified and controlled? And what were the threats to design validity in the study? Other questions? If the study included a treatment, was it clearly described and consistently implemented? Were extraneous variables identified and controlled? And what were the threats to design validity in the study? Was a pilot study performed? What was the reason for the pilot study? How adequate was the manipulation? What elements should have been manipulated to improve the validity of the findings? Based on your assessment of the adequacy of the design, how valid are the findings? And is there another reasonable, valid explanation for the study findings other than that proposed by the researcher? You will identify the elements controlled in the study, identify possible sources of bias, ask if there are elements that could have been controlled to improve the study design, and what elements of the design were manipulated and how were they manipulated. So I'm going back. Okay, we've just concluded the integrity presentation on clarifying quantitative research designs. We have looked at these objectives. So I encourage you to read your textbook carefully, download the PowerPoints, or at least view them, and view the integrity. This concludes week 10. Thank you.